Welcome. This series is dedicated to all of you who would like to have their questions answered about programming, game programming, and Unity. The question today is about Raycast. If you are new to my channel, my name is George Wulfers and I'm a professional game developer with over 10 years of experience. For the best tips and tricks on game programming and game development, subscribe to my channel and hit the bell icon to get notified when I post new videos on my channel every Monday. So what is raycasting? Raycasting is the action of tracing along a vector. Usually it has a starting point, a direction, and the length. This tracing of the line will check to see if it collides with objects within the world. There are several functions you can use depending on your goals. Pretty much you can shoot a ray and get a single or the first collision, or you can get multiple or all the collisions within the line. And as I said, it all depends on what you want to do. We will go over all of these functions or ways to perform a raycast in this video, so be sure to watch the end.
Alright, so let's get started on creating our raycasting. I have created a project in Unity. I called it YouTube Tutorials. So if you want to get that project, I'll be posting the link in the description below. So if you're following along with this project, or if you have a new project of your own, let's go into the scripts folder, and we are going to be creating a new C# script. We're going to be calling it Raycast Single. Let's open it up. Now if you just did what I did, and if it named it new behavior script and you renamed it, make sure that the names in the class match. I know that this used to be an issue. I don't know if it still is, but just in case. Alright, so let's explain some of this. So as we said before, the raycast needs a distance. So it needs a starting point, a direction, and a distance. And other stuff has been calculated down here, and we'll get to that. But pretty much what we want is to have a distance that we can change. And this enum is just letting us know if we're using array for raycasting, or if we're just using the non-ray version of the function that Unity provides. And this is just to let us know if we have hit something, so that we can draw the line or the ray that is being shot. In this update function, we are checking to see if we have pressed the left mouse button, and if we have, we're going to see what selection we have for this particular raycast. If it's not the raycast that uses the ray, then we will not use the ray, but if we are, then we will use the ray. And we'll talk about what the ray is in a bit. So the first one we're going to explore is the one that uses no ray. Okay. So what it takes, now that's actually multiple functions, and if we go over here and type in Unity physics.raycast, which is just the name of the function. And if we click here, or let's see what that is. Is that the same thing? It is. It's just newer. Okay. So we can see that this documentation holds pretty much everything that you need to know about how that function works, and it's even got some examples. If you want a link to this, I'll link it in the description below. But pretty much it tells you what there's multiple versions of this Raycast function, as you can see. But the one that we want to see is pretty much the one that uses for four things, which is a vector for the origin or the start, a vector for the direction of the ray, the Raycast hit information structure, and the distance of that ray. And we'll talk about what the other ones are. But let's see, for now, we'll just talk about this one. Where is it? This one's already the ray. Well, they don't have it here apparently, but we're just gonna pretend this one is the one that we want because it's got the first couple that we want. So as you can see, this particular function, for all of them, returns Boolean, either true or false, based on if it hit something or not. And you can see here, returns true when the ray intersects any colliders, otherwise false. Okay. So the origin is just the starting point in world coordinates, as it says here, of the ray. The direction is the direction you want to shoot the ray in. The hit info is that structure, and we can actually see it here. Raycast hit, and we can just open this up. So like I said before, when you use a Raycast, you're shooting a ray to see what object you hit in the world, and this Raycast hit class or structure holds all of that information. And some of the things that we want to look at or that we care about are the collider that we hit. That'll tell us what object we hit. The distance to see how far it was. It's got normals just in case you're trying to shoot down at the terrain, and if you're trying to position some objects based on the slopes of the terrain, you can use that normal, which is just the up direction or the facing direction of the triangles for that particular mesh, and based on that you can actually determine the position of that object that you want to place in the world. You also got the point, and that point is the impact point, not the actual location of the object that you hit. So just like the impact point, is it here, is it here, is it here? And you also have some other things like the rigid body, if you want to know about the rigid body, texture coordinates, transforms, which you can all get from Collider, and the triangle index. Those are all the information that you can gather from that Raycast hit. And some other things like the layer mask. And I've never really used the query trigger interaction, but it specifies if you have a trigger, if it should hit it or not. Because usually we just care about objects. But if you do want to know about if it's a trigger, then you can also do that. So what is array? And array, it's got a direction and it's got a starting point. According to Unity's version of the array, that's what it has, which is pretty much what we have in both cases. So if you take a look here, you can either use a structure that holds the start and the direction, like the array, or you can just pass the start and the direction by themselves. Either way is the same thing. They're just separated just in case it was more convenient to do that and you don't want to build this array. So what this function is going to do is it's going to shoot a laser from the starting point all the way to the distance that we selected based on the direction that we want to shoot in, and it's going to fill this out. That's why it has out there, because we're passing it in, but it's going to pop out, I guess, a result. It's going to fill this structure in for us to look at. And then we want to see if we actually hit, well, actually, if the collider that we hit, if it's there. I mean, it should be there, but just in case it's not, we're going to check for that. And then we just say that we did hit something, so we set it to true, and we get the starting point and the hit point that we hit, and we just output a message saying that we hit whatever collider name we hit and at what distance we hit it at. So pretty much these two functions work the same way. The only difference is that there's several differences. One is that you're using the array structure, which is, as we talked about, it has all of this information. It's just packaged into a single structure or entity or object or whatever you want to call it, and we just pass it like that. But it's got, as you can see, all of the same information, and it does pretty much the same thing, but instead of when we get the start point here, we just get the origin because it's the same thing. That's where it originated from. Now the difference here is that the way we are calculating the array, here we are just getting the position of this object, and we are getting the forward vector of that object in where it's facing. But in this case, we are querying the cameras. We're querying the camera, and we're passing in the mouse position. So we're essentially telling Unity to convert our mouse position to a screen coordinate so that we can shoot a laser from the camera. And if you've ever used Unity or any other, or if you've played any games that allow you to click on objects in the world, this is how you would do that. So pretty much here you could we could do anything when it hits. Like, let's say we're playing a RTS and you want to build something, or you want to tell your little guys to go somewhere, we would do that here. So that's pretty much it. Now keep in mind that if you don't have there's a camera called a main camera, and you have to specify which camera is the main camera in Unity. If you don't have any main cameras, that you can actually break the code here. So we may actually want to say something like that is null. Then we return and we want to throw an exception. Let's see which one. Is it like a null? Argument null exception. And I guess it'll return there, so we don't have to do that. And if you wanted to, you could pass in like a message, camera dot main was null or something, and maybe something like that. So we wouldn't want to execute that. And finally, what we're doing here on Draw Gizmos is pretty, you've seen this if you followed me on the current project we're working on. If pretty much what we're saying here is if we have hit something, or if we haven't hit something, then just get out of here. We don't want to do that. But if we have hit something, then we're just going to color the line red. So whenever you're trying to color any lines or any gizmos, the way it works is you set the color first, and then you call the draw line function. And if you want to draw something else in a different color down here, you just draw you call the color first, and then whatever you want to draw after that. All right, so let's go into Unity, and we are just going to let's create a game object and just call it Raycaster single, and we'll just have one. We'll save later. Let's put this guy in the origin, and let's give it some color. And so, damn it. For now, we are going to be testing out the we're going to add us one of these. We're going to add us one of these. We're going to add a capsule. And pretty much everything that we have here. Cylinder as well, and that's it. Only 4. So let's move this. Let's move it at 10. And then we'll do that. Maybe these two will be on that side of that quadrant, and these two over here. And let's go into the console, make sure that's visible, and make sure we have errors turned on. And okay, so let's talk a little bit about that main camera that we were talking about. So if usually by default when you create a new scene, it will have a main camera. If you delete it, this is how you would do it. Well, if you delete it, this is how you would get it back. Okay, so if let's say that we deleted this camera and now we don't have any cameras, to get a camera back and to set it as the main camera, we can create a new camera here and just tag it over here as a main camera. and that's it. That's all you have to do. So let's go ahead and put this back at 0, 0, 0, and maybe have it at -5. And maybe we want 5. And maybe rotation on the X would be -10 or 10. And that's it. Cool. So let's go ahead and play that. And before we do, actually, let's go back to the Raycaster single, and we need to make sure that we add our Raycast single. And so let's set the distance to be 100, and the selection is going to be UseRake at first. Okay. So we have this here. So now, if we click outside anywhere, not selecting an object, nothing happens. But as soon as you hover your mouse over something and then click on the left mouse button, you'll see that we shot a ray from the camera to this guy. And now we see here that it says Raycast no ray. Raycast no ray. Well, it's supposed to say Raycast using ray or something like that. We have hit cube at the distance of 15.75. And if we hit this guy, it now says sphere at 15.11, capsule, and cylinder. Okay, so now let's switch it to the no ray, clear that. And for this one, since this one's going to be shooting the ray from here this way, we have to make sure that they're all at the same X location. So I'm going to select them all, put them all at 0, but just do this, and let's play it. And all we got to do is just click anywhere, and it'll do what it's needed to do. And you can see the ray, right? Starts from wherever the position of this guy is, which is 0, 0, 0, and it goes all the way till it hits something, and it hit the cube. Now if we move the cube to the side and we do it again, it's now going to hit the sphere. If we move it aside again and we click, it's going to hit that capsule. And notice that it's only hitting a single object at a time. And if we move anything, then it's just not going to do anything. Okay, so that's how that works. Now, let's go ahead and look at the multi one.
Let me know in the comments below if this is making sense for you. I would really want to hear what you're struggling with so I can help you, better help you. Let us know what you would like to see next.
Okay, so let's go ahead and actually save this one. So save as, and we're just going to put it in the scenes, Raycast single demo. Let's do that. And let's go into the projects, and let's go ahead and create another C# script. And we're going to call it Raycast Multi, or Multi, whatever you want to call it. All right, so let's talk about this one now. Notice I just copied and pasted it because it was pretty much the same thing as the other one, except we're using different functions this time. All right, so we know what this is. We know what this is already and what these are, so we don't need to talk about them. Let's go and jump straight into the thing. So let's go into here and Raycast. Let's change this to all, and this is now what we were talking about. Okay, so if we read this part, it's going to tell us that it's going to return an array of Raycast hit objects. Note that the order of the results is undefined. So you're going to get a list, you're going to shoot array, and every time it hits, it's going to go from like the start to the end all the way through, and it's pretty much just gonna be like, oh, hit and put it in a bag, hit, put it in a bag, and hit, put it in a bag, and then and the order that it hits things is not going to be determined, so they can be jumbled up. But once you get it back, you could run some functions to order it if you wanted to, but we're not going to look at that because that's out of the scope of this video. So all you need to know is that this Raycast All function is going to return an array or a list of Raycast hits, because we're not just talking about one, we're talking about multi, or a lot, or all of them. So what does it take? It pretty much takes the same thing as the other one. You can see here, it can take array, a distance, layer mask, and a query trigger in interaction. And you also have some things here that you can look at. And just like before, we have a Ray version, but this one also has a non-Ray version, just in case you want to do the same thing we did back then. On the other one, you can pass in two vectors, which is the origin or the starting point, and the direction in which you want to shoot that ray. And it also has the max distance, layer mask, and query trigger interaction. Now notice that because it outputs a lot of Raycast hit objects, it does not take in any Raycast hit within the parameters here. Okay, that's very important to note. All right, so let's jump into it. All right, so we are gonna pretty much start off the same way that we started the other function that is also called UseRakeHasNoArray. no array. And we're going to pass in the same thing, the transform position and the transform forward direction. But instead of just having a single hit info, like we said before, we're going to have several. And we can actually just do that to simplify that line. So pretty much we're passing the same thing, the start vector, direction vector, and the float for the ray distance. And it's going to output a hit info. Now, be sure that probably, I'm not 100% sure about this, but probably if it doesn't hit anything, it might be null, so you better check for that. Okay? We don't know that. It doesn't say in the description, so we don't know if it's going to be null or not, so just check. So if it's not null, and if the length is greater than 0, meaning that it has something inside, then we're going to pretty much loop through every object in here. But before we do that, now you could do it in a for loop or a for each loop. I decided to go into a for each loop because I didn't think I was going to use the index, but I am using the index, so I just left it like that, and I have a separate counter. You could use the I in the for loop if you wanted to in this case, but I just did it like this because I was lazy and I didn't want to change it. But the way we are calculating the start point and the end point here, it doesn't really matter because that's just for us to visually see the ray. So if you were making anything, you would just care about that hit point and maybe a certain object within that hit point. But for us, we're putting the starting point before that for loop because we don't need to keep on telling it what it is when it's not going to change. The only one that is going to change is this one, but we are only doing it when we are at the end of that list. Looking at the index pretty much at the length minus 1, if you know what I mean. And so, yeah, we're doing the same thing. We're just checking for the collider to be there. And we're saying if it's, we are telling it that we actually hit something, so it is true. And we're outputting something, pretty much the same thing that we outputted on the previous version of this one. But instead, we're also putting out the count or the index that it hit, so that we can actually know how many we hit and which ones we hit. Now, okay, and same thing for this one, for the UseRake Raycast or whatever. We are still going to be getting the ray from the mouse position, from the screen, from the camera, and we're going to convert that into the world coordinates. And then we're just going to be calling this function same as above, except we're just passing the ray and the ray distance, because the ray contains the starting point or origin and the direction that we want to go in. And it's going to output hit infos, an array of hit infos. And we're still going to be checking to see if it's null or empty. And if it's not empty, then we're going to be doing the same thing as we did above. We're going to set a count to 0. We're going to get the starting point of the ray. We are going to loop through each ray info instead of hit infos. We're going to check to see if the hit info collider exists. If it does, we are going to do that, tell it that we hit something, and let's just put that out there. So we're going to be getting that endpoint. The reason why we're doing it like this and not like this, it's because there's no reason. You could do it either way, because this one is just going to actually, now that I think about it, when they said that, that's why it wasn't working correctly when I was trying it. I'll let you know. Let's continue, and when we hit that issue, I'll let you know what it is. But anyway, let's continue. And then we're gonna display the same thing that we're displaying, and we're counting up the count, the counter, to as we move from object to object, checking. Okay, and the draw, the on gizmo draw or the on draw gizmos is going to be the same as the previous one, so I don't need to explain that. Alrighty, so let's go into Unity. And we're gonna save this as script scenes. We're gonna save this as Raycast multi demo, and we are going to position the camera like so, and we're going to rename this guy to be multi, And we're gonna remove this component and add this guy, and we're gonna use Raycast first. And save that. So let's play it. And let's set up that angle like this so we can see it. So this one's the raycasting, using the ray, using the camera. So we're gonna shoot the ray, and let's see what happened here. You can see in the console that we hit 1, 2, 3, 4 objects. The first one was the cylinder, even though it's at the back. The second one was the capsule, even though it's right there. Third one was the sphere, which is technically the second one. And the third one was the cube. So as you can see, it goes from the last one that it hit to the first one that it hit. So now I'll tell you that issue that I was having and that I just realized. So I was wondering why it would only hit here even though it hit everything, right? And the way that I currently have it is that we're just replacing that end until as we go, because I thought that it would store it from closest to farthest, but it doesn't. It stores them the backwards. So when it hits this one, it would have shown it here, but then as it moves through the list, it shrinks it until it reaches here, because this was the last one that we went through on that for loop, or that for each loop. So if we wanted to fix that, we would have to find the furthest point. So distance, and we're gonna set distance to be the max value. And every time here, we're going to calculate the current distance, and we're going to be saying, okay, what's the distance between the starting point and the hit info point? And if, so we want the biggest one, we want the farthest one. So if current distance is larger than that distance, then that means that there's another distance farther away from us. So we want to make sure that we take that one into account. And only if that happens, we'll switch the endpoint for that new one. And we should be also doing it up there. Like that. So now let's go back in here. And let's shoot on the ray down the middle. That is interesting. UseRake. Why is it going to We actually want the min value here because we want to start far away from where we want it, because if we start here at the max value, that means it's going to be infinite. And if we're trying to see which one's the furthest, that doesn't make much sense because we're never going to reach this point. This is always going to be larger no matter what. So we have to make sure that distance is actually the minimum, which is negative infinity, on the opposite side of the spectrum. And that way it'll have a chance. So I think we did both. Yeah, we did for both of them. So now third one's the charm. There we go. So now we can see a ray that goes through every single point. So you can see it hit there, it hit through here, hit through there, and through there. So it's kind of like a kebab or something. Anyway, so now that we know how that one works, and you can see all the outputs and the distances, let's go ahead and check the other one, which is no array. And let's move the camera up and away, which we don't really have to. And let's play it. And all we gotta do is just click anywhere, and you can see that it also works fine, shooting a ray from the middle all the way through every object and stopping at the last one because it's the last one there.
If you have made it this far, congratulations! You now know what raycasting is and how to implement the various types of queries using Unity and C#. If you would like to download the project, the links are on the description below. If you enjoyed this video and if it provided value to you, hit that like button. It really helps us with the algorithms so more people can watch it. If you haven't already, subscribe to my channel. It's free. And don't forget to share it with your friends or with someone who will benefit from it. And before you go, want to check out these other videos on game programming and game development. Thank you, and as always, have a safe day, and I'll see you next week.